Hello friends, this video on magnetic effects of current part 5 is brought to you by examfear.com. No more fear from exam. So we will now look at the magnetic fields produced by different types of current carrying conductor. Now this conductor can be a straight conductor, that means a straight wire carrying current. So what kind of magnetic field will be produced by that? We will mainly talk about the pattern of the magnetic field lines in this case, the direction of the magnetic field. Secondly, we'll talk about a circular loop. If you have a circular loop of wire which is carrying current, so what kind of magnetic field will be produced in that case? We will also talk about solenoid. So we will discuss each of these one by one in detail. So let us start with magnetic field due to a current carrying straight conductor. So when I talk about a straight conductor carrying current, it is somewhat like this. That means you have a straight wire which is carrying current. So in this case, what was observed? So in this case also the same kind of experiment was performed. There was a wire which was carrying some current I. So the magnetic compass needle was taken and it was placed near this wire. So it was found that it showed some deflection. Now the amount of current was varied. So when the amount of current increased, the deflection also increased. When the amount of current was decreased, the deflection also decreased. So what did this show? This showed that the deflection is proportional to the amount of current. And what is this deflection? This deflection is nothing but a result of magnetic field. Right, because the compass always deflects only in presence of magnetic field. So this showed that magnetic field, we generally denote magnetic field by a capital B. So magnetic field was directly proportional to the current flowing through the conductor. So that was one observation. Then the next observation was that when the needle was taken far away from this wire, the deflection was less. But when this needle was brought closer, the deflection was more. So that means magnetic field was inversely proportional to the distance. Later in your higher classes, that is in your class 12, you will learn how to derive an expression for magnetic field for a straight current carrying conductor. So there you will see that all these things will come out true. So when you actually derive an expression for magnetic field, right? So these were some of the things which were observed. So the conclusion was that as far as magnitude of magnetic field was concerned, magnitude of magnetic field at a point increases as the current through the wire increases. That is, magnetic field is directly proportional to the current. The second observation was that magnetic field produced by a given current in the conductor decreases as the distance of the point from it increases. That means magnetic field was inversely proportional to the distance of the point at which we are measuring the value of magnetic field, right? So that was an idea which was received about the magnitude of the magnetic field. Now what about the pattern of the magnetic field lines? How will the magnetic field lines look like? Because we talked about the pattern of magnetic field lines in case of a bar magnet. In bar magnet, how did they look like? They formed continuous closed curves. They originated from North Pole and terminated in South Pole. Now, in order to determine the pattern of field lines, an experimental setup was done. So in this, there was a straight current carrying conductor. So this is your current carrying conductor, this straight wire, right? So it was connected in a circuit which had a variable resistance and a battery and a switch. So it was connected in a circuit. So when you switch it on, that means when the key is closed, current flows through this wire. Now another arrangement was done. A white sheet of cardboard was fixed here somewhat like this, such that the wire carrying the current is perpendicular to the cardboard. So you have fixed a cardboard here. And a lot of iron filings was again taken and put over this cardboard. So what happened? The iron filings again arranged themselves in a specific pattern, in a pattern like this, in a pattern of concentric circles. So in order to determine the pattern of magnetic field lines, every time this experiment was performed, you place that magnet and then you put the iron filings. They will themselves arrange get arranged in the pattern of the magnetic field lines. That is what had happened in case of bar magnet also, right? So in this case also the same thing happened. The iron filings arranged themselves in the form of concentric circles, keeping this wire carrying current as the center of the circle. Right? So from this it was assumed that the magnetic field lines around a straight current carrying conductor are in the form of concentric circles. So concentric circles represent magnetic field around a current carrying straight wire. Right? So this was the pattern of the field lines. Now what about the direction of the magnetic field? Now, in order to determine the direction of magnetic field in case of a straight current carrying conductor, came up this rule which is known as right hand thumb rule. Now, this right hand thumb rule, the name itself tells us what is it all about. That means it will make use of your right hand and it will also make use of your thumb. So, it says that if your thumb represents the direction of the current which is flowing through the wire, then the direction in which all other four fingers curl represent the direction of the magnetic field. So here you can see that if your thumb represent in this direction, that means your thumb points to the direction of current. So if current is flowing in this direction through a straight current carrying conductor, in that case, since your fingers are all pointing in this direction, they are all getting curled in this direction, that means there is a magnetic field along this direction. That means magnetic field is present around this wire in the form of concentric circles in a clockwise direction, because it is a clockwise direction, right? Similarly, in case the current is in the upward direction, let us suppose if current is in this direction, so you can try it yourself. Take your right hand, put your thumb in the upward direction. So what do you see? All your fingers will point along this direction. So that means current is flowing in this direction, which is anti-clockwise. I mean, the magnetic field is in anti-clockwise direction and in the form of concentric circles. So using this right hand thumb rule, we are able to determine the direction of magnetic field. So now you got an idea about magnetic field due to a straight current carrying conductor. For a straight current carrying conductor, the magnitude of magnetic field is directly proportional to the current, inversely proportional to the distance, and the pattern is in the form of concentric circles, and the direction is given by right hand thumb rule. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.